Okay, let's have a look at how we could go about carrying out exercise 215. Now I'm going to show you one way of doing this. One of the beauties of R, or some people think it's the curses of R, is that there is an extremely large number of different ways to do the same thing. So just because I've used this particular way of doing it doesn't necessarily mean it's the best way of doing it. I'm sure, in fact I'm almost certain, there are many other ways of doing it, and some may be better, some may be worse. All I'm concerned about here is that we get a presentable histogram, and that we are able to answer the two questions that are posed, which are to do with what the mode and the median of the data. So anything that will give you that answer will be acceptable. So this is just one way of doing it. Okay, so what do we do? Let's go through this code. First of all, we need to get the basic frequencies or counts into a vector. And that's basically what we are doing here. We're creating a vector with the counts in, and we're assigning it to something that we call here an object that we call hap.count, happiness count. Okay, so let's just highlight it and run it. Very good. So now we have that. You can see over here, this is now we've got this available to us now, and we'll want to use it a little bit later. What else might we need? Well, at some point we're probably going to be calculating relative frequencies. We don't just want the frequencies, we probably want the relative frequencies as well. In order to calculate those, we need to know what the sum of all of these counts are. So let's use a generic function, sum. What are we going to sum? We're going to sum up the contents of hap count, and we're going to put it in something called n, where n stands for the sample size. And we'll just print that out after we've done it so that we know what that is. Okay, there we go. It would appear that in this data set, if we add up all of the counts, all of the frequencies, 2,238 individuals were asked this question about their happiness. Okay, on to the next thing. We are not just interested in the frequencies, we're also going to be interested in the relative frequencies. Why are we going to be interested in the relative frequencies? Well, we might want to plot those, but this will also give us our answer to the question about what the modal category of the distribution is. So if we want to know the mode, we're going to have to look at the relative frequencies. Well, actually we don't. We can actually just look here and see where the largest number of observations is, but let's do this anyway. So what are we going to do? We're simply going to divide all of the entries in this vector here, hap count, by n, by 2,238, and that'll give us the proportions in each of the categories. There we go. And we can immediately read off down here, surprise, surprise, the modal category is the middle one, the one with the neutral label. Okay. While we're doing this, why don't we also look at the cumulative relative frequencies? We've answered the question about what the mode is, but to answer the question about what the median is, the most convenient way to do that is to look at the cumulative relative frequencies. So let's use another generic R function, this time the one called cumSum. That will basically take all of the entries in this relative frequency vector here, and it will produce the cumulative. the cumulative sum. Let's just run that. And here we have what it's done down here. As you can see, the first entry down here in the cumulative relative frequency is the same as in the relative frequency. And the next one is simply the sum of that one and that one. And this one here is the sum of that one, and that one. And this one is the sum of the first four, and so on. And from this we can read off very easily what the median is. In the first category, we just have just over 10%. Here we have 23%. Here we have 40%. Okay. Recall the median is the value that splits the distribution in two, so clearly it can't be in any of the first three categories. The fourth one, we have 60.5%, 60.6%. Clearly the median must be in this category here. This category is again the neutral category, the one in the middle. So both the mode and the median are in the neutral category. Right, now we have to use a little trick. So what kind of variable have we actually got here? Well, in reality, happiness, if we think we can measure it at all, is presumably continuous in some sense. We can be a little bit happy, we can be very happy, and so on and so forth. Quite what numbers we should attach to these labels is very difficult to know. The labels themselves are often known as vague quantifiers. But from the point of view of making a histogram, which is what we're asked to do, we need a scale on which to plot this. Now, in some sense, this scale is arbitrary, but the scale, an integer scale of 1, 2, 3, 4, 5, 6, and 7, is as good as any other. We don't really have any other information about how these categories should be spaced out. So why don't we just go with the integer values from 1 to 7. So we're going to make some use of those. So again, we want to have them available to us. So we put them in, we make a vector or a vector object called midhap. And these are going to be the scores that we are going to use. Right, well, we're making good progress here. The next thing is not obvious at all. We're going in a moment to use again a generic R function for making a histogram. But what that function wants is not quite what we've got. And we need to use yet another generic R function, the replicate function, REP. And the best way to see what this does is actually for me to just run it and then show you what the result is. You can see that it takes two arguments. One is midhap. Well, midhap is basically just the contents of this vector here, which contain these scores for each of the categories, 1, 2, 3, 4, 5, 6, and 7. And hap count is actually what we constructed right at the beginning up here. This is just the vector of the counts, the number of observations that are found in each of the happiness categories. So whatever this replicate function does, it does something with both of these pieces of information. Now let's run it, and then I'll come down here, down to the console, and simply type in mid count, and you can see what it does. Okay, so it's taken the first element in the midhap vector here, which is 1, and it has replicated that 234 times. So one were to count all of these ones down here, you see on this line here starts at 209. There are in fact 234 of these, and there are 276 twos. So again, if one was to count all of those, what a tedious thing to do, you would find there were 276, and so on. So essentially it's taken each of these integer values here and it's replicated them the number of times that are contained in this vector here. And that's the kind of input that the generic histogram function in R requires. So in fact, this new vector called mid count is actually what is going to be the input into the histogram function. All right, so the next thing is we need to do a little bit of housekeeping. We need actually to tell the generic histogram function where to cut up the x-axis essentially. Okay, and so we just put in the midpoints of all of the histogram bars that we want. So let's just do that. We just need to create that. This is again just a vector, and we're going to make use of that vector in a moment. Right, we're ready to make the histogram. So let's come down here, create a histogram as an object. I'm going to make it as an object because actually I would like to be able to manipulate the histogram, to tidy it up a little bit, to add some value labels, a title, and so on, and do one or two other things to make it look a little bit nicer. And so the way to do that is to create the histogram as an object. So we basically assign whatever the output from this generic histogram function here is to h, and that becomes an object, and we can then work with the object later. All right, histogram here, you can see, well, it in fact will take a number of different arguments, but we're only going to use two arguments here. First of all, we're going to tell it, okay, what's the content of the histogram? It's mid count, and we're going to then make use of this vector here, which we've assigned to break. These are going to be the cut points, or on the x-axis, the break points. So let's run that. And there we can see down here in the plot window, we've got some default output. Okay, so let's take a little look at the default output that we've got here. The first thing that strikes me is it's not very pretty, and some of the labeling is a little bit mysterious. We have no idea what these categories mean here. If this is and in fact the integer values are in some ways a little bit misleading. If this is a plot of one's subjective happiness, it's unclear whether one means that you are very happy or one means that you're very unhappy. One would seem to suggest a low level of happiness, but actually the first category in the list is extremely happy. So if we would just show this to someone, it would be really rather confusing, I think. There's also a few other odd things here. The scale here is the frequency scale. That might be what we want, but it only seems to go up to 400 here. That's not so nice. We might want to extend that a little bit. We possibly want a nicer label for the x-axis here. We possibly want a better label for the whole plot. And we really need to do something, I think, about these labels down here. We want something that's going to be a little bit more informative. Okay, let me resize the window so you can see a little what's really going on here. Okay, let's just put it there for the moment. Okay, we've made this object H, so we can take that and we can mess about with it. We can pretty things up a little bit. The first thing we might want is to have a nicer label down here on the x-axis. So I don't know, why don't we just say happiness or something like that, something that tells us a little bit what the x-axis is all about. Now by default it's basically printed out the values basically of each of the categories 1 through to 7. That's not what we want, so we can turn those off. Here is basically an option within the generic plot function, and that basically turns off those default x-axis labels. So we say x-axis N for no. I'm not a great fan of unnecessary shading. By default it uses this grayscale here. I would rather have the contents of each of the histogram bars white. So let's change the color to white. Let's have an informative title up here. How about, how would you rate yourself on a scale of happiness? So an option main allows us to change that. And why don't we also fix this Y scale here so it goes to a sensible value? It's clearly 400 is too short. Let's set it at 500, so it's going to run from 0 to 500. Okay, that's going to fix a lot of things. That leaves us with these labels down here. Now we've turned them off with this option here, but we need to substitute something else. Okay, so what we use is this command here, axis. Axis takes a number of arguments. One means the first axis. The first axis is the x-axis. We then define basically a sequence here, basically a sequence of numbers from 1 to 7 incremented in 1, and to these we're going to attach some labels. So we need to define another vector here, a labels vector, and this contains informative labels. So the first one, extremely happy, and that's going to be assigned to the number 1. Very happy, I leave the happy off because of course if we put too many words down here we have to think a little bit about the aesthetics. It's going to get very crowded and very busy, so perhaps we just keep happy anchoring the both extremes, extremely happy, extremely unhappy. So extremely happy is going to be assigned to the first position, very to the second position, somewhat to the third, neutral to the fourth, somewhat to the fifth, very, in this case, unhappy to the 6th, and extremely unhappy to the 7th. Okay, let's see if this tidies up our rather untidy plot. Okay, this begins to look a little bit better, but notice something a bit odd down here. This is a function of the size of the plotting window. If you make the plotting window too small, it will leave some things off. So let's resize that. Okay, so now the plot looks kind of reasonable. I would be pretty happy with that actually. I can think of only one improvement, and that is to make this not in terms of frequencies, but in terms of relative frequencies. The plot is going to look very much the same, but the scale, rather than being a frequency scale, would be a relative frequency scale, in fact in terms of proportions. So let's just resize that so as we can see everything in the window up here. Most of the contents of this this next bit of code is basically the same as before, but I've changed one or two things. The most important is this one here, frequency equals false. So this is going to coerce it to not give us the frequency scale, but actually give us a scale in terms of proportions or relative frequencies. And to make that clear, why don't we have a proper label? So we'll add a y-axis label. It says proportion. If I didn't add that, it would actually by default print the word density, which is also fine, but is perhaps a little bit mysterious for some people. And up here we need to change the limit. So now this scale here is going to be on the proportion scale. So obviously 0 to 500 makes no sense. Choose a sensible value. 0 to 0.25 or something like that would probably be a kind of sensible scale to use. Okay, and let's now then highlight this and run it. And there we go. You can see we have everything on the proportion scale. Nice labels down here. Nice title up here. Unfussy, plain white aesthetic. Looks quite reasonable to me. Okay, that's one way of doing this. If you found some other ways of doing it and it works for you, that's also great.